In this video, we're going to start looking at chapter 14. So chapter 14 is our chapter all about statistics. So we start off in this first section by going through a lot of definitions and a lot of terminology to help introduce us to some things that we see commonly in statistics. So first, we need to know what is statistics. By definition, statistics is an area of mathematics. And the focus of statistics is we want to gather, organize, analyze, and make predictions from information. And the information that we are collecting is our data. So when we are collecting this data, this information, we have our population. So our population is considered to be the collection of all outcomes, responses, measurements, or counts of interest. So the population is all of the data, everything we've collected. Now, we also have what's called a sample, which is a subset or part of a population. So your population is everybody. It might be everybody in nursing, everybody in Kirkman, whereas the sample would be a smaller collective group. And it's very important that when we're doing an experiment, a survey, we're collecting data, and we choose a sample that it's representative of the entire population. And often we choose a sample because it's not always realistic to be able to collect data from every single individual in the population we're focusing on. So a sample needs to be a good representation of the population so that that data can be meaningful. So we refer to that collection of information as data, as we stated already. Data can fall into one of two categories. It can either be qualitative or quantitative. Qualitative data is going to consist of information that's characteristic. Examples of this would be eye color or gender. Quantitative data, on the other hand, gives a meaningful numerical measurement. So what we are going to do first and foremost is think about the fact that this qualitative data, this characteristic data, can be organized into what we call a frequency distribution. Because as we're collecting data, as we're doing this experiment or the survey, we're getting all of this feedback. We want a way to represent that. And we want a visual representation for that so that anybody can look at all of the information in a way that's easier for them to understand. So in constructing a frequency distribution, which is what we're going to start off with in this section, first we have to figure out the count, which is the number of times a particular thing occurs. And so from there, we calculate what's called relative frequencies, which would be the number of times that particular event occurred compared to the total number of occurrences we have. So in the first example, we are going to build that frequency table. And so we're going to list the values in the left column, and then the frequencies and the relative frequencies are going to be in different separate columns. Now, typically the way we visually represent this data and this finding is with a bar graph, okay? That is one way we visualize a frequency distribution for qualitative data. When we draw a bar graph, we're going to specify the classes. So the classes are just the different categories. Those are going to be on the horizontal axis, so the x-axis. The frequencies would be how often that particular classification occurs is going to be on the vertical axis, so on the y-axis. So let's just get into going through a couple of these examples so that we can help all of this start to make sense and see how it all connects. Okay, so example 1. The following data represents the modes of transportation at campus of 20 students in a math course. So we are going to construct a frequency table, a relative frequency table, and a bar graph for the data. So we notice we have all of our data summarized. We have all of the responses from those 20 individuals. So the first thing we need to do is fill in that left column, which are the different modes of transportation. So these are what we mean when we refer to the classes. The classes in this case are the different modes of transportation that were reported to us when we collected our data. So we have people walking to campus. We have people biking to campus. Skateboarding, so I'm just going to write skate. Taking a car or taking the bus. Okay. And for the frequency table and the relative frequency table, those modes of transportation are going to be the same because we're using the same data to construct both of these. So to get the frequency, that's just going through each of these different modes of transportation and counting how many times does someone report using that mode of transportation. So if we start with walking, we have 1, 2, 3, 4, 5, 6 people that said they walk, so that's the frequency. Biking, we have 1, 2, 3, 4, 5, 6, 7 people that bike. Skateboarding, 1, 2. Taking a car, 1, 2, 3, 4. And taking the bus was just one individual. So what we are going to do now is notice there's a row at the bottom for the total. So we're going to add up all of the frequencies, 7 plus 6 plus 2 plus 4 plus 1. When we add all of those together, the total is 20. Now this is a really good way to check yourself, because if we look back at the problem we were given, we want to think about how many students did we survey? 20 students. So these frequencies should add up to equal 20. If they didn't, that means we probably just accidentally skipped over one or we counted one multiple times, which is why I always like to cross them out as I go through. So the frequency is different from the relative frequency. The relative frequency is a comparison of how many times does that particular frequency occur with respect to the total number of responses we received. So for walking, we said there were 6 people that walk. So 6 out of the 20 people walk. So when we calculate that, 6 divided by 20, that's going to be 0.3. With biking, 7 people out of 20 bike. So that's going to be 0.35. With skateboarding, 2 people out of the 20 skateboard. So that's going to be 0.1. 4 out of 20 take a car. So that would be 0.2. And just 1 out of the 20 takes the bus. So that would be 0.05. And when we add all of those relative frequencies together, we find that they total to be exactly 1. Now with our probabilities, we know that sometimes when we look at those decimals, they're not as exact and definite as these are. Sometimes they require us to round a little bit. So because of that, there are times where we will have a very, very slight difference. It might not be exactly 1.00. We might have 0.999 or 1.001. Those are both acceptable values when we're calculating the total, because with rounding, there is human error. And because we have to make that distinction on where to round, there are those occurrences where the probability won't be exactly 1.00. So that minute difference, if we encounter that, that's okay, that's acceptable. We don't want to have a big variance though, because if so, then that means we made a mistake somewhere. So let's go ahead and look at constructing a bar graph with this data. Now we can draw a bar graph using the frequencies on the vertical axis or the relative frequencies on the vertical axis. So we're going to look at doing both to see the similarities and the differences between them. So when drawing our bar graphs using our frequency or our relative frequency, you can use either one to represent the data that you've collected. What you'll notice is, with how I've already set mine up, the modes of transportation are what are represented along that horizontal axis across the bottom. And on that vertical axis on the left, you have either the frequencies or the relative frequencies. So what we're going to do is draw a bar for each class, and the height of that bar is going to either be whatever the frequency was for that mode of transportation or whatever the relative frequency was for that mode of transportation. So we have walking. So that had a frequency of 6. So we'll draw our bar for walking. We have biking. That one had a frequency of 7. Skateboarding had a frequency of 2. Okay, and so notice with this, the bars are not going to be touching. Car, people, 4 people said they drive a car, and 1 person said they take the bus. Using the same process with our relative frequencies, 6 out of 20, so that would be 0.3 was that decimal for walking. 0.35 for biking. 0.1 or 0.10 for skateboarding. 0.20 or 0.2 for taking a car. And 0.05 for taking the bus. So that's how we would take our data and represent the frequencies or the relative frequencies in a bar graph. So let's look at another example of calculating the relative frequencies and constructing a bar graph. So this example tells us the frequency table describes the living arrangements for adults in a certain country. We want to calculate relative frequencies and use them to construct a bar graph. So with this particular problem, when we're calculating the relative frequencies, we are going to use 3 decimal places. So we're going to round them to 3 decimals. So I want you all to just take a little bit of time, pause the video here, and go through and fill in that frequency or that relative frequency table, and then construct the bar graph. Okay, and so then once you've done that, go ahead and resume the video so that you can compare to see if you filled in the table correctly and if your bar graph matches. Okay, so after you fill in your relative frequency table, you would have your different categories or living status in the left column. And then remember to get the relative frequencies. You're going to take the number of individuals in that particular class, so the number of people living alone, and divide it by the total number of people. And you do the same with each of those categories to get those decimals. Then, and we did say because we had to round, this does happen on occasion, when we add up all of those, notice this one does not equal exactly 1.00. It ended up being 1.001, and we said that minute of a difference is acceptable because of rounding errors. Okay, so that does happen a lot of times when we're rounding those decimals that just tend to go on, and we have to put a stopping point to them. So then we use the relative frequencies and the different classifications to construct our bar graph. So we had the relative frequencies on the vertical axis and the different classifications on the horizontal axis along the bottom. And so notice I drew my bars, the height corresponding to the relative frequency, and I did just round to the nearest tenth, and I wrote above each bar what that decimal is, just for representation of how high up that bar should be drawn, especially when you look at the last few classes. All of them are decimals that are relatively close to each other. And so just wanting to establish the fact that the height of that bar does correspond to the decimal, even though it might look a little bit closer to whatever that tick mark says on the vertical axis, just distinguishing that the height for those living in the other status is not actually at the 0.2 height. It is a height of 0.18. Okay. So the last thing we're going to look at in this video, and this is going to be a part 1 of 2. We'll do the last few examples in a separate video. But last thing we're going to look at in this video for this first section is another way to represent data called a stem and leaf plot or stem and leaf display. And so with this type of display, you can use this to represent one set of data or multiple sets of data, specifically 2 sets. And that's what we're going to look at here. It's very beneficial when we're looking at a side-by-side analysis. So you'll notice we have our columns on the left that say A, our columns on the right that say B, and then we have that area in the middle. With a traditional stem and leaf plot, you have your stem and you have your leaves. And when we draw a traditional stem and leaf plot, our leaves, the leaves are the rightmost digit of that number. So, for example, if we had 48, the way we would represent that on a stem and leaf plot would be 4-8. So, if we had our different groupings, our stems are the ones, not the ones, the tens or the digits that are not of the most right. So if we had our set of data, our stems would be like 1, 2, 3, 4, representing the 10s, 20s, 30s, and 40s. And then the leaves, if we had like 10, 15, 18, 22, 35, 37, 43. So we're going to very similarly divide up this stem and leaf plot, or divide up the data into the stem and leaf plot for both sets of data. So what we are going to do first is fill in the middle, okay, with our stems, because the stems are going to go in the middle. So those are going to be, for this problem, all of the digits in the tens place. So we're going to compare both sets of data. And we notice all of the data is from something in the teens to something in the 40s. So our stems are going to be 1, 2, 3, and 4. Now for the leaves, so I'm going to do A in blue and B in green. So with filling in that side for A, we're going to start with the tens. So we always arrange these from smallest to largest. And you can see that kind of with the example I have of a stem and leaf for a single set of data. But for 2 sets of data, especially this one on the left side, we start with our tens. So we go through and we have 15 and we have 18. So we list the smallest one first. Now, the smallest digit is always closest to the stem. So it would be 5, and then we move out. So in this case, we're moving to the left. So it would be a 5 to represent the 15 and an 8 to represent the 18. I always like to, as I represent each data value, cross it out. So that way I know which values I have remaining. Those are the only values in the tens. So then if we look in the 20s, if we go through, the smallest one we have is 21. We have 22. I see that come up twice. So we put a 2 for each 22 because every single data value has to be represented. We have a 26. We have a 29. Okay, that's all for the 20s. For the 30s, we have a 32, a 33, a 34, a 37, and we have, let's see, 39 shows up 1, 2, 3 times. 1, 2, 3. So 3 9s. And then in the 40s, we have 42. We have another 42. 43 shows up 1, 2, 3 times. And then 47. And so when we're finished filling in our stem and leaf, what we want to do is just count how many leaves do we have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. If we go back and count how many data values we started with, that number should match. So if we look back, we do in fact have 20 data values in set A. Now we're using this for set B as well because we're comparing the data here. So again, we're going to start with the ones, or not the ones, the tens. So when we go back and we look, we've got, I see 14, 13, and 18. So when we fill in the right side, it's going to be similar to what I have up in the top right. The smallest ones digit, the smallest digit in the ones place, is always closest to the middle. So the 3, and then we move out. We increase and get bigger as we move to the right. So 13, 14, 18. And then we do the same thing with the next group. So we've got 20, so 0 represents 20, 21, 22, another 22, a third 22, a fourth 22, and then we've got 23, 25, 26, 28, and 29. If we look at the 30s, we've got 32, 33, 33, 38, and 39. And then we've got 45. So we have all of our values represented. So this is how we fill in a stem and leaf display when we've got two sets of data that we want to compare side by side. Okay. So in the next video, we'll look at the last bit of this section, and that'll wrap up 14.1 for us.